Hey algebra students, it's Mr. D'Amico with another lesson for you. Today we're going to be talking about solving inequalities. Our goal is to solve inequalities using algebraic properties. So first we're going to solve, then we're going to graph the solution on a number line, which we've done before, and we're going to write the answer in interval notation. Now that's new for us, interval notation. The nice thing about inequalities is that they follow the same logic when you solve them as in a linear equation. When you solve an inequality, you want to do the opposite. For example, if it's y plus 3, you want to subtract 3 from both sides. And your goal at the end is to get the y by itself. But instead of being equal to something, it could be greater than or less than, and so on. So what an inequality is if an equation has an equal sign, the inequality, like I was just saying, has greater than signs, less than, greater than or equal to, or less than or equal to. That's what makes it not equal. I know it could be equal to, for example, here or here, but greater than or equal to, and also less than or equal to. So there's more than one solution. There's an infinite amount of solutions that exist. What's interval notation, you might be thinking? Well, interval notation is just the way that we are going to write our solution when we're solving inequalities. And basically, since there's more than one solution, you want to give all the intervals, like the smallest number to the greatest number, and everything in between there would be a solution to the inequality. So sometimes, like a less than or a greater than sign, a number is not part of the solution. We use parentheses. So you're going to see when we write our interval notation, we're going to use parentheses when the number we're talking about is not part of the solution. However, when the number is part of the solution, like on less than or equal to or greater than or equal to, we're going to use brackets. So you can see the difference there. Parentheses when a number is not part of the solution, but brackets when a number is part of the solution. And sometimes you use one of each. So let's try an example. 3n divided by 4 is less than or equal to 2 times the quantity of n minus 3. Well, the first thing I'm going to do is distribute the 2, and that's going to get us 2n minus 6 on the right side. A couple of options here. What you could do is we could go the opposite of minus 6. We could add 6 to both sides, but what I'd like to do is deal with this fraction first. Since the denominator is 4, and if you look, that's the only denominator in the problem, I'd like to multiply both sides by 4. That will eliminate my fraction, and then I can just be dealing with integers. So on the left side here, when you multiply something by 4 and divide by 4, that'll cancel, or you can think of it this way. 4 times 3 is 12, and 12 divided by 4 is 3, so that'll be 3n on the left side is less than or equal to, and then we're going to distribute the 4, and it's going to give us 8n minus 24. Let's subtract 8n from both sides, giving us negative 5n is less than or equal to negative 24. Divide both sides by negative 5. Now, something happens when you divide or multiply by a negative number in an inequality. Do you remember what that is? Well, in Algebra 1, we learned that whenever you multiply or divide by a negative number, and it's an inequality, the inequality sign switches. So basically, what we have here is we have our less than or equal to, since we're dividing by a negative 5, changes to a greater than or equal to. So n is greater than or equal to 4.8. Let's put that on a number line. Now, since it's less than or equal, since it's greater than or equal to, we are going to put a closed circle on 4.8, and it's going to go to the right, because we know as we go to the right on the number line, numbers get bigger, so that's greater than, and the equal sign is why this is a filled-in circle. So everything, the numbers 4.8 and larger are solutions to this inequality. Now, how do we write this in interval notation? Well, we always go from the smallest number to the greatest number. So the smallest number in this solution is 4.8. Like I said, it includes 4.8, and then it goes on to positive infinity. So the smallest number is 4.8. The largest number, since it goes on forever, is positive infinity. This is a closed circle, so the solution includes 4.8. So that gets a bracket. You can never get to infinity. Infinity is not a number. It just keeps getting bigger and bigger and goes on and on and on. Since infinity is not a number, we do not put a bracket there since it can't equal that number. It can just approach it. That gets a parenthesis. So this interval notation indicates that the answer to this inequality is all the solutions starting at 4.8 and every solution that's bigger than 4.8. Okay, example number 2. Let's start out by distributing the 5. And how about we add 55 to both sides? And then all we have to do now is divide both sides by 10. 4 is greater than x. Now before we graph it, I don't know about you, but what I like to put my x on the left side of the inequality sign, or at least read it that way, because 4 is greater than x means that x has to be, if you read it backwards, x has to be smaller or less than 4. If you think x is greater than 4, that's incorrect, because if you look at this sign here, the open side, the mouth is opening towards the 4, so when you rewrite it, the mouth still has to open towards a 4. So these two mean the same thing. 4 is greater than x is the same as x is less than 4. Now it is a little bit easier to graph. Because it's less than, I'm going to put an open circle on the 4. And because it's less than, again, I'm going to go to the left. So 4, not including 4, and everything smaller. So this time, as we go further and further to the left, that's negative infinity that the graph approaches, and positive 4, but it doesn't include 4. We already know the infinity will get a parenthesis, and this time the 4 will also get a parenthesis because it does not include 4 because of the open circle. It's everything less than 4. So there's your interval notation, from negative infinity up to 4, but not including 4. Second part deals with compound inequalities. Well, a compound inequality is similar to a compound word. In a compound word, it's 2 or more words put together. In the compound inequality, it's 2 or more inequalities put together. In this case, we're going to deal with 2 inequality signs put together. And if you think about the compound inequality, there's 2 types. They have the word and, or they have the word or. And I'm going to explain the difference with those in a second here. An intersection is an and problem. The solution to an and problem is where the graph overlaps. So that's the intersection, where the 2 graphs, they cross, they overlap. That's the solution to an and problem. On the other hand, the union is a solution to an or problem. When there's an or problem, the graph could overlap, but usually it doesn't. Usually it goes away from each other. So in the union or the or problem, the solution is any part of the graph, not just the part that overlaps like the and, but it could be any part that's graphed. Typically on a number line, an and problem, which is an intersection problem, the graph, they go towards each other. On the other hand, typically on a number line, a union problem or an or problem, the lines go away from each other. So that's something to remember for that. Let's go on to example 3. Negative 9 is less than or equal to 4y minus 3, which is less than or equal to 13. Now I don't see an and or an or. However, what I see is 3 parts here. First part, middle part, and the right part. This middle part, the 4y minus 3, is referring to the negative 9, and it's also referring to the 13. So it's in the middle, it's overlapping. So really, if we think about it, that's one inequality. Negative 9 is less than or equal to 4y minus 3. But then the 4y minus 3 also is paired with the 13. So the second inequality is 4y minus 3 is less than or equal to 13. So if we write it out like this, since that 4y minus 3 right here, since it's circled twice, that's an intersection, therefore it's an and problem. See, this is where the overlap is. Both circles overlap at 4y minus 3. That's why we treat it as an and problem. Now let's solve each side separately. And this is going to turn into a fraction. Negative 6 divided by 4 is negative 3 halves, is less than or equal to y. And if we solve the right side, we're going to get y is less than or equal to 4. Let's make a number line. Now I have two numbers here. I have negative 3 over 2, which is negative 1.5, and I have 4. So I put the one on the left that's smaller. Negative 3 over 2 is smaller than 4. The one on the right is greater. Obviously 4 is greater because it's positive. And again, I want to think about it as with the y listed first. If negative 3 over 2 is less than or equal to y, I want y to be greater than or equal to negative 3 over 2. That means the graph is going to be a closed circle going to the right. And for y is less than or equal to 4, that's going to give me a closed circle going to the left. And remember we said and is the intersection. So where these two graphs overlap and intersect, that's our solution. Now there's no infinity this time because if you look, it starts here. This is the smallest value that's shaded in where the intersection is, all the way up to where the largest value is. It does not go on forever. I know the graphs go on forever, but since this is an and problem, we're only concerned about where they overlap. So the smallest value, since it's a closed circle, is negative 3 over 2. The largest value, since it's a closed circle, is positive 4. Since they're both closed circles, they both get brackets. That's the answer in interval notation. There's no parentheses for this one. There's also no infinity. All right, last example. It's definitely an or problem. You see the word or there. Let's solve it individually. M is greater than 4, or remember when we divide by negative 2, we're going to switch the inequality sign so it'll become less than. M is greater than 4, or M is less than negative 5. So let's draw our number line. Negative 5 goes on the left because it's smaller. Positive 4 goes on the right because it's bigger. So now I'm going to graph M is greater than 4. So that should be an open circle going to the right. This should be less than negative 5, an open circle going to the left. Okay, there is no overlap here. So the solution to this is everything, like since it's an or problem, it's every part of the graph is a solution. And what does that mean? Well, if we look over here, sorry about that. If we look over here, that's better. Since this goes to negative infinity, we want negative infinity, and then it stops at negative 5, but it doesn't include negative 5. So those would get parentheses. And then it starts at 4 and goes to infinity, but it does not include 4, so there are no parentheses there either. I'm sorry, there are no brackets there. We only use parentheses. And now you look at that. There's two parts. We haven't had anything like this before. Well, recall back earlier on the worksheet it says that or is a union. So what we want to do is we want to show that it's not just these that are part of the solution. It's not just these that are part of the solution. It's these together that are all a part of the solution. So a union means we want to bring both number sets together. This first set, this second set together. And we put a symbol in here, which is the letter U, that signifies the union. So if someone's reading this, they say, okay, the solution to this inequality is all numbers from negative infinity up to negative 5, not including negative 5. Then it skips up to 4, not including 4, and all the way up to infinity. So there's a lot of numbers there that are part of this solution. All right, you can see that it's time to begin the work on the back. There are 4 problems on the back that I'd like you to try right now. The answers are in the right-hand margin. Please come to class tomorrow ready to ask questions. Good luck on these 4 problems, guys. Thank you so much for watching Solving Inequalities. Have a great day, and I will see you tomorrow. Bye, guys.